Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics are Rising Up. That special channel created for you and I to come together to demystify mathematics and tackle the age-long phobia often associated with this all-important subject, one topic at a time. Thanks so much for staying tuned. Don't forget to like, share, subscribe, and most importantly, tune in your button so that you'll be the first to know when our subsequent videos are uploaded. Thanks and stay blessed. Today we are looking at the continuation of the topic algebraic fraction. Specifically, we are looking at the operations of algebraic fractions. In the last video, we actually looked at how to multiply and divide algebraic fractions. In summary, all we need to do was to factorize each numerator and denominator in the given question until we have common factors, which can then cross out, until we have as simple as possible a solution. Pretty simple, I believe. Today, we are going a step higher by looking at the other two operations, which are addition and subtraction of algebraic fractions. Pretty much similar to adding and subtracting numerical fractions, we use emphatically the LCM of the denominators. So it's pretty much the same here, except for the involvement of letters, and that's what makes it algebraic fraction. Let's see how it pans out. To start with, let's simplify this question. We've got 3 over 8d plus 5 over 6e. So the denominators here are 8d and 6a. So the question is, what is LCM of 8d and 6a? Of course, we have to take the numbers first. The LCM of 8 and 6 to start with is 24. That's the lowest common multiple. It's 24. So the LCM of d and e is also de. So together, the LCM of 8d and 6e is 24de. Then just like we do in numerical fractions, we see 8d in 24de. That will be 8 in 24, 3 times the 3, that's 9. So d here we cancel out the half e left, that is e. Then plus 6 in 24, that is 4 times 5. That's 20, and e cancels e, we have d. And that's pretty much the solution there. It's that straightforward. So the addition is simply 9e plus 20d over 24de. So without wasting time, let's take the second example there. We have, we've got example 2, 3a over 2a plus b minus b over 4a plus 2b. Again, the starting point is the denominator. Denominators here are actually 2a plus b and 4a plus 2b. So it might be a bit cumbersome to take the denominator here. However, if you look closely at the second denominator, it's a multiple of this, meaning 4a is actually 2 bracket 2a plus b. That means the first denominator is embedded in the second denominator. We can then simply say that, okay, our LCM is actually 2 bracket 2a plus b, which is the bigger one. That's the LCM of the denominator, because we can find both inside this. So we go on and say, okay, 2a plus b, we cancel 2a plus b, we are left with 2. 2 times 3a, that's 6a, minus, so this 4a plus b is cancelling the entire, this 4a plus b as well. That is 1, that is b. And that is pretty much the solution, because you can't bring this further than this. I believe you found that quite straightforward and interesting, really. So, we go further now by taking example 3. And then we have 3c over c squared minus d squared minus 3d over d squared minus c squared. Okay, once again, the starting point is always the denominator. So the denominators here apparently look different, because we have c squared minus d squared here. On the other hand, we have d squared minus c squared here, which are not the same. However, on looking closely, we can modify this d squared minus c squared to be the same as this. Also, factorizing that by bringing out minus 1. Hence, we can say d squared minus c squared is same as minus 1 bracket c squared minus d squared. So we're going to have then 3c over c squared minus d squared minus 3d over, remember we have written this as what? Minus 1, then what? C squared minus d squared. That becomes 3c over c squared minus d squared plus, because minus divided by minus is plus, then 3d over c squared minus d squared. We can now clearly see that the denominator is 1 and the same. Hence, we have c squared minus d squared. And we have the same denominator. This in this is 1 times 3c plus the same thing, 3d. Do we stop here? Not so. What the question says, simplify as best as possible, meaning you have to keep on breaking down until you can't go further. We can still go further here, we can't stop. Because clearly, if I calculate the numerator, I'm going to have 3, then bracket c plus d over, don't forget, this is difference of 2 squares. So that is going to be c plus d, c minus d. So this cancels out, we have 3 over c minus d as the final answer there, which I believe you found quite interesting and easy. Then we have lastly here, question 4, which says that we should simplify 7h plus k over 2h plus k all squared plus 3 over 2h plus k. Okay, as usual, the LCM of denominators. Denominators here is actually the same thing really. So we have just 2h plus k all squared. So this and this is 1 times the numerator 7h plus k plus 2h plus k, we cancel 1 out of it. That is 2h plus k left times 3. 2h plus k. So by simply opening the bracket there, I'm going to have this plus 6h plus 3k over 2h plus k all squared. So at this juncture, we can now simply add the like terms. 7h plus 6h is 13h, and k plus 3k is 4k. That's 4k over 2h plus k all squared. And that's basically, that's about that. And I believe you found this as interesting and easy as possible. So, that's been the end of our lecture today, which is on addition and subtraction of algebraic fractions. If you find this as interesting as I expect, please don't forget to like, share, subscribe, turn on the button so that you'll be the first to know when our next video is going to drop. Thank you and stay blessed.